Welcome back to the workshop. We want to take one last look at differentiation, just reminding ourselves of a few rules on differentiation. So let's see here. I'll go ahead and share the screen really quick and just look at these. Of course, we're not using the limit process every single time that we take a derivative. So essentially we do pattern recognition and we say the derivative d over dx, assuming x is the variable here, the derivative of a constant k is 0. All right, what's the slope of a horizontal line? Nothing. Again, the graph is a nice, easy way to interpret and understand what's going on, but it's not, right? It's not the most general interpretation. Rate of change. Remember that, rate of change. Derivative of a constant is 0. Constant in multiple rules. So say I have some differentiable function f, and then d over dx of k times f of x is equal to k times f prime of x. That constant multiple rule just follows right along, or the constant multiple rule says the constant just follows along. You can pull the constant out essentially when you're taking a derivative. The power rule. So the power rule is something that's kind of interesting because it's relatively easy to prove the power rule when it comes to positive integers, right? 1, 2, 3, 4, 5, 6, and so on. Really easy to prove the power rule then, but the power rule works way more than that, right? This is n times x to the n minus 1, and it doesn't matter if n is positive or negative or a rational or irrational number. The only thing it can't be is 0, can't be 0, and it can't be -1. No, it can be -1. Can't be 0. No. Yeah, I think that's it. All right. If it were 0, then it would just be the constant. So that doesn't work for us. All right, so next would be sum and difference rule, the derivative of the sum or difference of two functions, d over dx of f plus or minus g is the same as the derivative of f plus or minus the derivative of g. Now, what is this really saying? Well, this kind of says that we can take the derivative of the functions individually. So really it's saying this. We can split the derivative over addition and subtraction, or distribute rather. So derivative of f plus or minus derivative of g. All right, product rule, the derivative d over dx of the product of two functions, f times g, is f prime times g plus g prime times f. I suspect and hope that some of these were covered a little bit more thoroughly in Calculus 1, showing how we get these rules, because it's worth considering. For those of you that move on to real analysis, you'll actually investigate each of these again. For now, write them down on a cheat sheet. That's absolutely fine, right? We can use cheat sheets on our exam, so that's not a problem if you need to know these. In fact, I think that I give all of these differentiation rules to you, so you don't even have to write them down. So bonus there. Derivative of a quotient. Oof, got to remember this one here. Let's see here. G times f prime minus f times g prime divided by g squared. Now this one's kind of hard to remember, so having it written down or having it available, of course, is nice. But this is how it was said to me. It's a nice little rhyme. Low d high minus high d low over the square of what's below. It rhymes. It sounds kind of weird. D, of course, is derivative. Low d high is the derivative of the numerator. Low d high minus high d low over the square of what's below. So anyway, it helps me remember. And then the chain rule, if I want to take the derivative of a composition f composed with g of x. Of course, this is the derivative d over dx of, if we look at the definition of composition, we're just taking the derivative of that. And when we can recognize that, we take the derivative of the outside function, leave the inside the same, and then multiply by the derivative of the inside function. All right. Are there other ones that we can consider? Yes, right. We have the basic trigonometric derivatives and a few other things that we should be aware of already. So there should be a sheet outlining each of these in the text. So feel free to take a look at that, and I will share a version of that for our exams. So let's see here, some examples to follow. So I'll see you guys back in the workshop in just a minute.